that. Let's think about another problem. Another problem you might have is, well, those goods, while you call them the same thing, they're not the same. That is, goods really are getting better over time. Okay? How do we think about goods getting better? Is there an easy way in the framework that we've put on the board so far to talk about improvements in the quality of goods? That is, goods are getting better over time. Yeah?
Possibly you break it down like we did for the groceries. You basically say, like, you get the cell phone, the cell phone from 1990, like, has this much computational power. But you look at components and things like that, like trying to figure out the price. I don't know, that's the way it's better.
Yeah, so you're saying I could do kind of a characteristics approach, right? I could price the characteristics. I could say, well, a cell phone's not a cell phone. A cell phone is really defined by some set of capabilities. Or you think about computers are easier. You might say, I'm going to measure the processing power. I'm going to use MIPS or something like that. And I'm going to say, what's the price of a MIP, right? What's the price of a teraflop of computing power, whatever it is. I come up with some units and I measure it. Or I take my cars and I characterize them by miles per gallon and a bunch of other characteristics, and I price the characteristics. And that's one way to get equality. Okay? But there might be another way to get equality. So let's think about a simple model of quality. And one model of quality that economists use, I'm not saying it's always the best model, but it's a simple model, is to think about quality as effective, higher quality equals a lower effective price. So the idea is 1 unit of today's good equals K units of the old good. And this you can think of as kind of a special case of your world, where I'm just saying whatever the stuff is this thing has is K times as much as what the old one has, right? That is, the quality is K. So if you thought about what our model would imply, let's assume that prices and income stay constant now, right? Again, I'm assuming away all those complications. I just want to think about it. I'm going to assume that prices and income stay constant. The only change is that this good changes and I get K units for every unit I buy now, right? It's like buying candy bars. They made the candy bars bigger, right? That's it. That's all they did. Or I got my computer, it just goes faster, right? And all I care about is the total number of computations I can do. So if I didn't know K, let's think about what this implies about the data. What would the data look like? What would xi look like now if xi is the good that got better? So xi would be equal to what? It would be xi of p1 up to pi minus 1. What would the price be? What would it basically be? Pi divided by k. That is, the per unit price would be effectively reduced by the factor k, right? The cost per unit is half of what it used to be if k is equal to 2. Pi plus 1 up to Pn and m. That would be the amount of good I that I would buy, except for I got to multiply by 1 over k. Why? Because this is how many of the old units I want at the new price. But every old unit only requires 1 over k new units. Anybody understand why? Think of it this way. Candy bars used to cost 50 cents for 1 ounce. Now, they're 50 cents for 2 ounces. You want more candy bars or fewer? Well, think about it. Price per ounce went from 50 cents an ounce to 25 cents an ounce. So you want more ounces. No question you want more ounces, right? But he sees why you want more ounces. Ounces are cheaper. So every ounce of candy costs half as much as it used to. So I want more ounces. But does more ounces mean no more bars? What?
A bar is now 2 ounces.
Right. So what if demand had unit elasticity? Demand minus 1 demand elasticity. So when the price per ounce fell in half, I would want twice as many ounces, which would require exactly the same number of bars I was buying before. Right? What if demand were inelastic? Demand were inelastic, I would want more ounces, but not proportionally more ounces. Less than proportionally more ounces, so I would end up with fewer bars. If demand were elastic, it would go the other way. I would demand more than twice as many ounces, and therefore I would demand more bars. So actually, the demand for this good could go up or down as its quality improved under this model. It gets up in quality, I'd use less. Okay? It's not at all unusual, right? Right? In the world, if we make tires last longer, well, people buy fewer tires. Why?
Inelastic.
Why is the demand for tires inelastic?
You can only have one. I mean,
No.
well, you can only have one set of tires in your car.
Yeah. But the number of tires you'll have won't be completely inelastic, right? Number of people driving around without a spare will go down when tires are cheaper, right? You'll replace your tires before they go bald, right? You'll do lots of things that will actually cause you to consume more tires, right? Your tire consumption in the sense of effective tire miles, think about it as tire miles. Tire miles will go up. But why is the demand for tire miles inelastic? What makes us think the demand for tire miles is inelastic? Well, what if the demand for driving were elastic? Would that be enough?
No, because even still tire miles. It's just that it's important to have tires.
Yeah, okay, so think about it. Let's assume you don't care about tires, you don't care about anything, you just like to drive, right? That's the model. What's in that utility function is driving, right? So the price of tires effectively tire miles falls in half, right? So the price of a tire mile goes down. Okay, so the price of tire miles is half of what it used to be. Price of driving has gone down how much? Much less than that, depending on the share of tires in the total cost of driving. If tires are 10% of the cost of driving, then the cost of driving went down 5%. Right? So even though I doubled the tire miles, unless the demand for driving were super elastic, I would not demand more tires. So two things going on. The demand for driving itself might be inelastic, but even if it were elastic, tires are a small share of overall driving. Now, I've assumed that tires and driving are used in fixed proportions. Now, that's not exactly right for the reasons I said before. You won't run your tires down as far. You won't always carry a spare, but it's probably close enough that it's not going to overwhelm this share effect, right? So demand is going to be relatively inelastic for tires. On the other hand, for any one tire manufacturer, if they made their tires last longer, what do you think would happen? They would sell more tires, presumably. Why? Well, think about it. The demand for their tires is elastic. right? The demand for any one manufacturer's tires got to be elastic, right? Why would I say it has to be elastic?
It's really good substitutes.
Well, that's one reason. There's an even better reason. What if it wasn't elastic? What should they have done? They should have raised the price, right? You would think they should raise the price if it wasn't elastic because they could get more money, right? Because they would collect more revenue and have to produce fewer tires. So you would expect demand for individual tire manufacturers' tires to be elastic, okay? But also, I think the reason you gave is the right underlying reason, which is there are a lot of good substitutes, namely other tires. You're not depending on people driving more to sell more tires. They're going to drive with your tires rather than somebody else's tires. That's the basic logic. All right. So the effect on the consumption of good I is going to depend on the elasticity. So you really, if you looked at the data and you saw the consumption went down, you really couldn't tell whether quality went up or down unless you knew which side of 1, or minus 1 really, the elasticity was, right? You couldn't tell. Or could you? Is there anything else you could look at in this simple experiment I put on the board? What would you want to look at? So let's assume your econometrics sucked and you just couldn't estimate the elasticity of demand for this good. So you didn't know whether it was bigger or less than minus 1. So you really couldn't tell off of the consumption of this good whether quality was going up or down. And obviously we care a lot whether quality is going up or down, right? Because if quality is going down, I'm worse off. If quality is going up, I'm better off. And if I don't know the elasticity, I don't even know which way quality is moving. What would you look at in this simple experiment where the only thing changing in the world was the price of this, the quality of this good? What should we see? What if I looked at xj? Well, xj would be xj of p1 up to pi minus 1, pi over k, pi plus 1 up to pn and m. How would that help me? Assume I don't know any elasticities, but I know something. What should I see? If this good is getting higher quality, what should happen in this good if it's a complement? Consumption should be rising for these complements, right? That is, I could read all, in fact, I get an idea of how much quality is going up by how much it's driving up the quantity of complements and down the quantity of substitutes. So even though a quality improvement for I has kind of an ambiguous effect on its own consumption, under this model it has a very predictable effect on the consumption of complements and substitutes. If this good is getting better, that means it's effectively getting cheaper. I should see people buying less of the substitutes for this good and buying more of the complements for this good. On the other hand, if this good is getting worse, people might have to buy more of this stuff because they really need to get the services, but I should see that reflected in the opposite changes in complements and substitutes. Okay, so sometimes looking at the complements and substitutes can be helpful because that you really can think about as measuring the effective price change in the consumption of this particular good here. All right, people see how that works. So you'd want to look beyond just the good itself where you have these kind of offsetting effects. On the one hand, it's better, so I want more use. On the other hand, it's better, so I don't need as many. On the other hand, the effect on complements and substitutes is much more direct because you only have the price effect for the complements and substitutes.